Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 26, 2026, about 4 days ago. It presents a unified multimodal language model that generates high-fidelity vector glyphs directly from text or images, achieving more than 2 times higher accuracy than general-purpose models like Claude Sonnet 4.5. The paper is titled VecGlypher, Unified Vector Glyph Generation with Language Models. And as we'll see later, the results demonstrate a massive leap forward for automated, professional-grade typography design. Figure 1 illustrates the 2 main ways users can interact with VecGlypher. In the top panel, showing image reference generation, the user provides a handful of reference images, seen here as the letters A, B, and D, and the model synthesizes the rest of the word in that exact style. The bottom panel demonstrates text reference generation, where natural language prompts like handwritten script or vintage drive the design directly. Crucially, as the far right column shows, the outputs are true SVG outlines with control points, which makes them fully editable and resolution independent. Well, to generate those editable outlines, the model relies on a strictly defined vocabulary of drawing instructions, detailed here in Table 1. The researchers simplify the full SVG standard down to just 4 atomic commands: Move to for starting a shape, Line to for straight segments, and Quadratic Bezier for the curves essential to typography. A final close path command seals the loop. By restricting the syntax to these 4 operations and quantizing coordinates to 1 decimal, they create a consistent token sequence that the language model can learn effectively. Alright, Figure 2 contrasts this new unified architecture with previous paradigms. In the top left, Panel A shows how prior methods relied on complex dual encoder-decoder systems, often requiring a separate geometry post-optimizer. The top right, Panel B, illustrates diffusion-based approaches, which typically cascade image generation into vectorization. However, the bottom panel reveals the key innovation. VecGlypher collapses these steps into a single LLM. Whether the input is a style description or a set of reference images, the model directly processes the prompts and auto-regressively emits those vector tokens in one efficient pass. So, Figure 3 details exactly how that single pass works. On the left of Panel A, the model accepts either image references or text descriptions, alongside the target character. These inputs feed into the central VecGlypher large language model, which predicts SVG tokens one by one to build the vector path. Panel B then outlines the 2-stage training recipe. First, Stage 1 uses large-scale supervised fine-tuning on noisy Envato fonts to teach the model basic SVG syntax. Then, Stage 2 refines it on high-quality Google fonts to strictly align the geometry with style instructions. Now, Table 6 provides the quantitative evidence backing up that training recipe. First, looking at the top section, scaling from 4 billion to 27 billion parameters delivers a massive jump in performance. However, the data strategy helps even more. The bottom rows show that the 2-stage approach, labeled E_G, is superior. By pre-training on noisy Envato data and fine-tuning on clean Google fonts, the model achieves the best geometry with a chamfer distance of 1.67. Additionally, comparing the representation columns R and A shows that absolute coordinates consistently yield better stability at this scale. Alright, with the training recipe set, Table 8 pits VecGlypher against general-purpose giants like GPT-5 and Claude Sonnet. The first 2 sections list proprietary models, which generally struggle. The best performer, Claude Sonnet 4.5, only reaches about 47 relative accuracy. In contrast, the bottom row show that VecGlypher 70B dominates the leaderboard, hitting over 100 accuracy and reducing the chamfer distance geometric error by nearly 70% compared to the strongest baseline. So, while the previous table focused on general models, Table 9 compares VecGlypher against specialized vector font baselines on image reference tasks. Here, the competitors are DeepVec Font v2 and DualVector. Looking at the first column, relative OCR accuracy, these baselines struggle, scoring between 38 and 49. In sharp contrast, the bottom rows show VecGlypher 27B reaching over 99% accuracy. The geometric precision is even more striking. The chamfer distance drops from roughly 15 down to just 1.18, while the FID score plummets from over 100 to 2.32. Wrapping up, 2 key takeaways stand out. VecGlypher proves that language models can master precise geometry, generating editable vectors directly without raster intermediates. This unifies text and image-based design, dramatically lowering the barrier to creating professional typography. It suggests a future where complex design tasks are handled through simple conversation. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.